Right, we're going to go through two really basic components, which at first glance look the same, but they do quite different things. Now the transistor we know quite well, all right? We've often plugged that into a microcontroller over here, which sends out a little signal into this pin here of the transistor, which then allows a much bigger current to run through and power something much more powerful, like LEDs, a buzzer, even a push motor. All right. First of all, we're going to learn how to label this one. All right. There's 3 pins. Okay. Collector. Okay, because it collects the main current in off the voltage rail. Emitter. Okay, because then it emits the current back down to the ground volt rail. Okay, and this here is the base. Okay, it's quite simple. You'll often get in the exam asked to write that up. Now the way this works is that current can't flow this way until this little gate here closes. Okay, now this is made of silicon. Silicon is a semiconductor. It will conduct electricity when it's been touched by a little bit of electricity. So if I send a little bit of current in here, it will suddenly make this plate conductive, which allows the main circuit to flow. All right. Often these are used as amplifiers, and we'll talk about that in a second, or switches. Okay, and that's the one where we've used it quite a bit. All right. The reason it's an amplifier is that this signal might not just be on or off, it might still be some sort of rising or falling analog signal, okay? And obviously at a really, really high signal, this becomes a lot more conductive, okay? Which means that this can allow much more current to come through. When it's lower, it'll be less conductive, which means less current comes through. So this isn't just an on-off switch. What it's actually doing is it's taking this signal and magnifying it, okay? So this signal over here will be exactly the same, okay, but bigger, okay? It's called amplifying, and that's what this one does. It amplifies. It's not an on-off switch. It's not digital. Whatever the input signal is doing, the big signal will match it, but will be magnified, all right? And that has another use later on where we take 2 of these, but we'll talk about that in another video. So that is the transistor. Collector, emitter, base. It can be used as an amplifier or a switch. It amplifies the base signal, okay, and makes the main signal coming through a lot bigger. All right. So bearing that in mind, we're then going to come to this one. This is a little bit different. At first glance, the thyristor looks like a diode, and as we know, a diode only runs in one direction. Okay. What it's got a gate. So this here is the gate, and like a diode, we've got an anode and a cathode. Okay? And if you do know your diodes, that's an easy one to remember. Again, when I get a signal in here, it turns on. But it's digital, so it's either on or off. Okay? It doesn't amplify, it doesn't magnify, do anything like that, it's just on or off. Problem with this is once the gate has been opened, you can't shut it. Okay? You actually need to get the signal to go around another way. So what you would do is add in a second circuit just here. So normally I want the current to come through this way, and I've turned it on maybe from a microcontroller. It opens the gate, the current runs through. I can't close the gate with that same microcontroller. What I might need is a push to make over here, which allows the current to bypass it, flow that way for a split second, which resets that. That is the only bit of additional circuit you need, okay? So this is a digital on-off. There's no analog, there's nothing else to it. It's on or it's off, okay? It's controlled by the gate. It looks like an anode and a cathode diode. Okay, and you need some sort of bypass circuitry. Easiest one is a push-to-make switch. That's it. Transistor, thyristor. Okay, I did the whole thing